Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Live here at Wilson's Pumps Incorporated on Norris Road here in Bakersfield. We're really looking to explore today how math ties into the work of supplying materials and repairs for pumps. And you know, pumps can take a lot of forms and have a lot of different applications. And we're going to speak to the folks here at Wilson's Pumps Incorporated about that. So we're going to start off with Mike Smalden. Mike, pleasure to see you today.
Yes,
Thanks
sir.
for having us.
Yep, nice to meet you.
Tell us a little bit about the work that you guys do here at Wilson's Pumps.
So we sell new units, we do repairs, and so we have customers that call with certain specifications on moving a certain product at a certain pressure, and we basically design it to fit their need, and then we also service it after the fact and do the repairs and field maintenance.
So explain to our audience what exactly a pump is and the kinds of businesses that require the services of one.
So they use the pumps in food applications, you know, your Frito-Lay, oil and gas installations, wastewater, you know, the water that comes out of your faucet at home went through a pump.
Basically anybody that needs to move a lot of fluid quickly from one place to another.
Exactly.
So what does that process entail? How does that exactly work?
Well, as far as like a water installation, so it'll basically, the pump will boost it and pressurize it so that it can come out of, you know, your faucets, flush your toilets, etc. So we will basically design it to fit their need.
So these are machines that are designed to take a lot of fluid, put them under a lot of pressure, and use that pressure to move it to another spot.
Exactly.
So if you don't mind, let's go ahead and take a look at the shop.
Sure.
And kind of guide us around what we've got to work with here.
Sure. So like this is a new unit that customer came to us with a certain application, needed to move, you know, so much product, so much pressure, and we will design it, get with the factory, and set it up for their need. So this one's getting ready to go out the door, and we'll actually help install it and test run it, etc.
It looked like, I mean, you know, we have a lot of different sized units for what we've seen so far. Where we start off in the first room, those appear to be a little smaller than the ones we have here.
Right.
So you've got to be able to scale some of these for different capacities or sizes of fluids that you're moving, as well as densities, I would imagine.
Absolutely. Yeah, I mean, this is somewhat standard or small for what we do, but there's pumps the size of semi-trucks.
Now
I mean,
now you're just bragging. This is
No.
one of our smaller units.
Right.
And you know, it's not just the pumps themselves, but it's also the smaller pieces in some of the components.
Right.
And we have one of those over here.
Right.
And we're going to meet with Ivan Crawford here as well. Ivan, thanks for having us as well.
Very
So tell
much.
us a little bit about the piece that we're working with here today.
This is a crank out of a positive displacement pump that we work on. So we got a mic clearances and kind of would tell how much wear is in this between this bearing and this journal.
So now this is a piece that's been repaired or refurbished.
This would be a repaired piece. And what we do is we go and grind off these parts right here, and then they'll spray them back up or weld them, and then turn them back down to fit.
So you guys are in the business as well of taking old pieces and making them newer again. And one of the things you do is, like you said, you measure exactly how much of the original piece has been worn off through the years of wear and tear.
Yeah, so we from the manufacturer, we'll get a piece of paper that says that this should be a certain size, and then it'll give us a minimum clearance and a maximum clearance in both inches and millimeters. So it's kind of good to know both sides.
And if you noticed on that sheet, ladies and gentlemen, you know, these measurements are in very precise increments. We're talking maybe thousandths of an inch. And that's not something you can measure just with the naked eye here.
No, so to put it to perspective, a thousandth of an inch. Your hair is about 2/1000ths of an inch thick, so it would be literally splitting hairs.
That's not funny. I don't need that. All right, we were friends, Ivan. We're still friends. Let's. But so if you can't just use your eye to make those evaluations or a standard ruler, you guys have to have specialized tools for that.
Yeah, we have to have a specialized tool. So this is a micrometer, and you can see on the barrel and the thimble by moving this one way or another, it'll measure. This is set at 8 to 9 inches. This is what divides the inch up into thousandths of an inch. So as you would read it, then you would take a measurement and write it down and compare it to your notes, and versus what would be on there for brand new, it would show your wear in here. This is a set of inside micrometers.
Oh wow.
So we would also have to measure the inside diameter, compare it in there. It would give you a maximum and a minimum clearance, and depending on that, it would kind of tell you if it was good or bad, or if we needed to replace it, or that's kind of how it works.
Now, what's really interesting about these micrometers is that they're built with a range in mind. Like, you have to be able to measure something that is, for example, with this tool, between 8 and 9 inches in length. You have to know that already before you refine it down to get to a precise measurement.
Yeah, so and they come in sets. So this one here is
Oh, wow.
yeah, this is a 3 to 4 mic, and they'll go from 0 to 1 all the way up. That one's 11 to 12 set. So anywhere in between that, up from like a 0 to 12 inches, we can mic.
So you've got increments of 1 inch for every range between 0 and basically 1 foot.
Yes.
That's fascinating. That's really interesting to be able to know kind of your area. You can estimate first how large it's going to be before you pull the right tool, and then you can refine it to find that precise measurement. And you guys are big into recording everything. I mean, it's right there on the piece.
Yeah, and then for this piece right here, we actually use what's called a plasti gauge, and you cut a couple of pieces and you sit in here, and then you have to put the cap back on and re-torque. And when you pull this off, it'll have smashed that little piece in there, and it'll give you a scale that you can read, and it'll tell you if it's got anywhere from 2 to 6 thousandths clearance on it. So it kind of...
Yeah. I mean, precision measurement is a key of the craft here. And when we come back for our next segment, we're actually going to take a look at how the team here designed an equation to make some interesting conversions regarding how much fluid to move in one day as far as a rate from one to the other. And it's a lot more complicated than it originally appears, but then a little bit of work files that right down to something more skillful and useful to use. Back here at Wilson's Pumps Incorporated with Mike Smalden. So Mike, we were talking about a pretty common scenario you have when taking orders from clients that need a certain pump that meets a certain capacity. Kind of walk us through that.
So most of the time they ask us, or their unit of measure is barrels per day. So 1 barrel of oil is 42 gallons. It's a measurement that's been used since the late 1800s. And so a barrel of oil or water or whatever is 42 gallons. So all of our pump manufacturers, everything's in gallons per minute. So we end up having to convert to make that work.
So for example, you would have a client that needed a unit that moved 1,000 barrels per day. Well, you've got to get that to gallons per minute because of the work that you need to do with your manufacturers.
Correct. So we have come up, or we utilize a conversion factor. So, we start with 1,000 barrels a day divided by 34.29. So we know our pump needs to do 29.16 gallons per minute.
Now, that's an interesting number, that 34.29. And we were talking about how we got to that number, because that takes a lot of conversions. First of all, you're going from barrels to gallons, but you're also going from days to minutes. So you know how many gallons are in a barrel, but now you also have to consider how many minutes are in a day.
Right.
So we were kind of working on this over the break, and we figured that we would start off, let's say we have that 1,000 barrels a day. We had to multiply that 1,000 barrels by 42 gallons.
Correct.
Per barrel. So we know that 1,000 barrels a day is the same as 42,000 gallons per day. We then had to divide that by 24 because there's 24 hours in a day, and then had to divide that by 60 because there's 60 minutes in an hour.
Correct.
And we could have just figured out that there's 1,440 minutes per day and divided by that as well. And that gets us to this value of 29 and 1600 gallons per minute. Now that's the same number that we got to in the end here. And so we started thinking about, well, so what would you need to do to get to 29.16 from 1,000? So that ended up becoming like a division problem. At which point we got this factor of 34.29. Now that's really important because instead of having to do all this every single time, you have this conversion rate that you can apply to any number of barrels per day, or if you had gallons per minute, you can multiply it by that.
Correct.
And get that unit converted. So for example, if we had 2,500 barrels a day, and we have a unit that needs to move 2,500 barrels per day, instead of doing all this, we could just divide that by 34.29.
So it'd be roughly 73 gallons a minute.
And so that's really helpful. That's going to save you guys a lot of time. And that's something that you designed yourself as far as a conversion rate that you can apply in any of those situations. So instead of having to do this, I mean, how many steps are involved in this? Now you have just one step.
Correct.
So, I mean, we can apply that as an equation. We can say, if we have some variables, we can even use barrels per day as a variable. Let's say B divided by 34.29 would equal G, gallons per minute. So there's a lot of different ways you can build that, but you've essentially built your own equation that has an application just about every day with the work that you guys do.
Right.
So you've got another you've got another visual here that kind of takes that idea a little bit further. Talk a little bit about what we see here on this reference sheet.
So each pump will run on a curve. So depending on the flow and pressure is the point on which it's running at. So most of your customers will tell us they want to run at like a certain pressure, like 165 pounds, for instance. Well, the pump manufacturers, all of their stuff is in head. So you have to convert the pressure into a figure of head. So 165 pounds times 2.31 equals 380 feet, so which would put us right there. So basically we're converting everything back to where we can design it with the pump manufacturer.
And so what's nice about the visual is it takes the conversion rates and it compares two different units to get you into a range. And those ranges matter because that tells you what type of approach you need to take, what type of tools you need to use.
It's got to run in an optimal range so it lasts, so it has a long, lifetime of run. You don't want to, if it runs too far left of the curve or too far right, you have different situations that happen, vibration, you're going to have failures, and then we're going to be out fixing it.
So knowing what a range can do allows you to keep a proper watch and extend the lifespan of the equipment that you're working with. So you want to make sure that the pressure is right for the gallons per minute that the machine has.
Right. It's all about reliability. So we've got to make it last and make it run right, or they're not going to want to continue to use us or that particular product.
Because who wants to use a machine that breaks all the time?
Exactly.
So that's really interesting how that conversion rate ties into a visual for durability, but at the same time, it lets you design a tool and an equation that will let you move fluidly, no pun intended, between barrels per day and gallons per minute. And that's all design. And so you guys have a lot as far as mathematical design with the approach that you utilize in your work. So when we come back from our break, we're going to talk with Ivan about how you can get involved in the industry here, what sort of interests you want to follow up with, and what sort of skills you want to bring into the field. Back here at Wilson's Pumps Incorporated with Ivan Crawford and Mike Smalden, just wrapping things up here on a Wednesday afternoon. During the break, you guys were sharing some wonderful experiences that you've had the opportunity to have a hand on in your work in the industry over time, as far as travel and also projects.
Yeah, we've had our hands in a couple of things. We worked on the wave pool at Mandalay Bay.
What were you saying for that one? 22,000 gallons a minute?
So the one of the pumps was capable of 22,000 gallons per minute. If you guys were paying attention to the equation.
Hey, you were paying attention, right?
So
I'm gonna follow that up.
So a swimming pool per minute.
Yeah.
Moving that volume.
Times 5, there was 5 pumps, and the other part of the whole thing that was we had to work with somebody else was the timing of the gates to allow that much to go through to create that wave without washing the sand off of the beach that they had out at back of the pool. So it was kind of,
This is basically a surfing competition that they wanted to bring to the desert.
yeah. Well, or even just, Johnny and his kids could go out there and do boogie boards or whatever.
They can play with that later,
Yeah.
but let's get the pros first. But I mean, it's wonderful, like, to hear about these experiences, getting to travel and getting to see the world. So if somebody wanted to get into this industry or this field, what would you recommend as far as a starting point? Let's say this individual is in 7th or 8th grade. What would you want them to focus on?
Most of it's going to be, don't be afraid to get your hands dirty and learn something and apply what's on paper to maybe hands-on approach. And, there's not a vocational school per se for this industry, but we have a lot of guys that start from the ground up, sweeping floors and different things. And we have guys that go to college or put themselves through school, and then they end up coming back working as an engineer, and they've got that hands-on experience, which makes them better at their job.
One of the things that you get to do when you get really hands-on with work is you make mistakes.
Absolutely.
And when you make mistakes, that's the best learning experience you could possibly have. And so, as far as, not just, the work you might do in classes, but as far as like physical capacity and capability, you want to make sure that you're constantly, using what you learn and applying it directly as possible with something that, allows you to make something or create and make those mistakes so that you don't make them in the future.
Right. And, this, we use math every day. And, a lot of kids or people will say, I'm not going to use math. Why do I need to? We use it on a daily basis. And everything that we do and every aspect of everything that we put together, we use math. And, I mean, being a pump mechanic, it's sent me around the world twice. So I've used math all the way around the world 2 times.
That's phenomenal. Well, gentlemen, again, I wanted to thank you so much for having us, in your shop today with the work that you've done to really provide that, outsider lens for, something a lot of people don't generally think about as far as how their world is impacted with pumps. And as we are always, happy to do whenever we visit our communities and explore how math works in the real world, we wanted to thank you and commemorate our occasion with our honorary Do the Math tile, as is seen across community partners around Bakersfield. And again, gentlemen, thank you so much for helping us and inviting us into our shop today.
Thank you.
Wilson Pumps Incorporated. Oh gosh, that would have been a YouTube moment, ladies and gentlemen. And again, thank you so much for having us, Ivan Crawford and Mike Smalden here at Wilson's Pumps Incorporated for a wonderful afternoon.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.